Yeah. Step 1 is to find the relevant elements on the periodic table. Across the top of the periodic table, remember we've got our Roman numerals, and we've also got our Arabic numerals. But the Roman numerals tell us how many valence electrons there are. So you might want to be looking at those ones. But if you're looking at the Arabic numerals, then once we get above 10, it's the last number. Okay, so it would be the 3 or the 4 or the 5, etc. That's telling us how many valence electrons there are. So once we know how many there are, we can look to see how many bonds each substance needs to make. So if we look up carbon, for example, you find carbon, which group is that in the periodic table? 14. And so how many valence electrons does carbon have? 4. Yep, okay, you're all speaking very quietly. So how many bonds does that mean that carbon needs to make to achieve noble gas stability? 4 bonds, yep. And if it was bonding with hydrogen, how many hydrogens would it need? 4 hydrogens, if they were all single bonds. Okay. What about if we were bonding with oxygen? Whereabouts is oxygen on the periodic table? So we're thinking about carbon and oxygen. We know that this is in group 4 or group 14. Where's oxygen? Group 16. So that means this one has 4 valence electrons and this one has 6 valence electrons. How many bonds are we going to need? We know that carbon needs 4 bonds. How many bonds does oxygen need? 2. And so how many oxygens do we need? 2. So in this case, if I have my 4 valence electrons from my carbon there, and with my oxygen it's going to be arranged that way so that we're forming a double bond with the carbon on that side and a double bond with the carbon on that side, so that they all have access to 8 electrons. And if we just draw the bonds out, we would end up with a linear molecule of carbon dioxide. Are you getting the... Can you see what we're doing? We must know how many electrons we have to start with. And we have to know how many bonds we need to make. We can also make double and triple bonds. We've seen a double bond here. Now, if I had another special property, if you like, of carbon, and we'll talk a bit more about this in a couple of weeks, is the ability for it to form double or triple bonds to other carbon atoms. Okay, so I could have a structure like this. where I've got two of the carbons with a double bond between them, and then the other bonds are to hydrogens. Now I want you all to have a go at drawing the electron dot diagram for this. And you can just chat amongst yourselves.